Hello, boys and girls. Welcome to Math 3. Our first unit in Math 3 is linear functions. And this is lesson 1 of Unit 1. And we're going to look at the range and the domain of functions. You can find these guided notes on pages 1 through 4 of your packet. Please follow along. Our objectives actually, we're going to find the range and the domain of a function. And then we're going to use interval notation to write the range and the domain of the function. We're going to determine if a relation is a function and then evaluate a function. Let's start with some vocabulary. Now, most of these words you probably have heard before in Maths 1 or 2. We're just going to kind of go over them just as a reference. So the first one is domain. The domain is the input value of a function. It is generally represented with x. Next, we have range. Range is the output value of a function, and it is generally represented with the y, or sometimes you might see f of x or g of x or w of x, but it indicates the range, the output value. When we identify the range in the domain, in this class we want to use interval notation. Interval notation is a way of writing a subset of numbers. And there's some nomenclature that goes with that. So if we want to indicate that the number is included, that a number is included in the solution set, we're going to use brackets. And we can determine if the endpoint is included by less than or equal to, greater than or equal to, or closed circle. If it's not included, if the endpoint is not included, we're going to use a parenthesis. And that would be notated with less than, greater than, or an open circle. Infinity is always noted with a parenthesis. Now this will become more clear with some examples. So here's just kind of a quick reference. This is not in your notes, but if you want to take a picture of it, that would be great. So what you want to notice here is that notice that you have both brackets. So that means both A and B are included in the solution set. And notice when we write it with less than and greater than symbol, both we have less than or equal to on each of these. Notice also closed circles. Okay, so that means that both A and B are included in the solution set. Our second example, notice we have parentheses. And neither A nor B are included because we simply use less than, and we don't use less than or equal to. Notice on your number line, you have two open circles. Now, you could have one closed and one open. Notice how we notate that. Or you could you could have the A open and the B closed. Okay? Again, when we do some examples of more clearly. Let's talk about a little bit more about vocabulary. We have the word function. A function is a relation, and a relation is a set of ordered pairs, such that for every x, there's only one y. The vertical line test is used to determine if a graph is a function. And the vertical line test says if a vertical line intersects a graph in more than one place, the graph is not a function. We have function notation. It's read as f of x. And this is actually the function notation, and it's read as f of x. And then we have a piecewise function. A piecewise function is a function broken into pieces by the domain, hence the term piecewise functions. Now today we are going to just evaluate piecewise functions, and later in the week we'll get into actually writing a piecewise function. So remember we talked about if a vertical line intersects the graph in more than one point, it is not a function. So these are some examples of functions and not functions, and we can determine that by the vertical line test. This first type of function is a linear function, which is what we're going to deal with mostly in this unit. It's linear. Notice this is my function. And when I drew a vertical line through that, it only touched it in one spot. It didn't touch it in more than one spot. And I don't know if you can see that, but if I were to draw a vertical line anywhere, it's only going to touch it in one spot. The second function is known as a parabola. This is a parabola. Again, all parabolas are functions. And notice that if I were to take a vertical line, it would only hit that parabola one time. This function is just a weird function. It has no name. It could be cubic. 1, 2. Could be cubic, a cubic function. And again, if I take a vertical line, I'm only going to hit that cubic function one time. Again, this is another random polynomial function, which we'll talk about, not for a while. But again, if you draw a vertical line, it only hits it in one spot. Okay? On the other hand, these are not functions because as I draw this vertical line, I hit the graph in two places, and therefore it's not a function. This is a circle. It's not a function because that vertical line is hitting it twice. And the vertical line, you only need to, if it fails one place, it fails the whole thing. So I only need to show that it hits that graph twice in one spot. Here it hit it 1, 2, 3 times, so it's definitely not a function. And again, it hit it 2 times, so it's not a function. Okay, so now we want to practice for a little bit. In these two relations, we want to determine whether or not they're a function, what is the domain, and what is the range. So remember, a relation is just the set of ordered pairs. So we have two relations here. And we want to determine if it's a function. So earlier we stated that a relation is a function if for every x value, there's one and only one y value. So every x value has a unique y value. In other words, x can't repeat. So what we want to look for to determine if it is a relation, does x repeat? So look at our x values. We have 1, -2, -1, and oh look, the 1 repeated, and its y value here is -2. Its y value here is 3. So therefore, since for every x there's not a unique y value, this is not a function. The domain is simply a list of the x values. So our domain in this case would be 1, -2, -1, and we don't have to repeat the 1. Now, I like to write these in numerical order. Notice also I'm using braces and not parentheses because this is what we call a discrete function, meaning that every value between -2 and -1 is not represented. So we use braces in this case. The range is simply the y values. So this is -2, 0, 2, and 3. Okay? So I want you to pause the video, try problem number 2, and then come back and see the answer. All right, so in problem number 2, we see that the x values do not repeat because we have 1, 2, 3, 4, 5. So yes, it is a function. The domain are going to simply be the x values. So we have 1, 2, 3, 4, and 5. The range is simply the y values, 1, 2, 5, 10, 15. Okay, so let's do another problem. Now, on this slide, we're looking again for the domain, the range, and the function, but we're given as a graph. So it makes it a little bit more complicated, but I have confidence that you guys can do this. All right, so the domain, remember your domain are all of your x values that are covered. Every x value that has part of the graph is in the domain. In this particular case, we only have two x values that are part of our graph. And that x value is -3 and 2. Again, we're not putting them in parentheses because it's discrete. It's not a continuous function. Now, our range are all our y values. So what is the smallest y value that we're going to see? Remember, y values are our vertical values. And because of the arrows, that means that this graph goes on and on and on forever in a negative direction. So it's going to go on and on forever, so we represent that with -infinity. And how about on the other side? It's going to go on and on forever in a positive direction, so we represent that with +infinity. So I'm just going to come down here because that looks like it's getting a little range. And I'm going to say the range is going to be parentheses -infinity, infinity. Remember, infinity is always included in parentheses. Is this a function? Well, remember we talked about the vertical line test? So if the function has a vertical line itself, then there's no way it can be a function. So we're going to say no because it passes the vertical line test. Okay? So let's do problem number 2. And let's look at the domain. So what is the smallest x value that we have? So all the way to the left, we see the smallest x value is -5. Notice there's an open circle on -5. And that open circle means that it's not included. So our smallest x value is -5. We're going to put a parenthesis because it's open. Our largest x value, we come over, it only goes to 5. There's a closed parenthesis there, so we're going to do 5, and that's closed, so it's going to be in a bracket. My range, once again, I'm going to write down here just because it's getting a little tight in there. So the smallest y value that I see is -2. Now, on the left, the -2 is open, but on the right, the -2 is closed. So that would go in a bracket. The highest y value is 2. Now, that's not an open circle or a closed circle, but there's a horizontal line on there. So that means that it actually went to 2. So that's going to have a bracket as well. And that bracket goes from -2 is included to 2 that's included. And that's the highest y value, the lowest y value. Now, this is a polynomial. It's a cubic polynomial. We'll learn that later. And it has arrows on both sides. So when it has arrows on both sides, that means it goes on and on forever. Oh, I'm sorry. Is this a function? Yes, this is a function. Oh, I'm having a hard time writing. Yes, that is a function because it passes the vertical line test. So let's look at our domain. Because it goes on and on forever in the left direction, even though it doesn't look like it's continuing on, it's going to go on and on and on forever. So therefore, its domain is -infinity. It goes on and on forever on this side to infinity. The range is, again, it's going to go down to -infinity, up to +infinity. So again, it's -infinity to infinity. Just a hint, all polynomials have a domain and range of -infinity to infinity. Is it a function? Yes, all polynomials are functions. So there we go. All right, I think you have 6 more problems to do in your notes. This is the end of this video. I want you to do the next 6 problems in your notes and then come back and we'll go over them and finish up today's lesson.